Hey, in this video we're going to take a look at how to convert logarithms into exponents and vice versa. We actually kind of did this a little bit in the last video, looking at an exponential equation and its relationship to a logarithmic equation. We're really just doing the same thing here. In this case, they're actually giving us an equation and asking us to change it to an exponential equation. So we're going to take what we have and we're going to change it into an equation. Remember how to say this? How do we say this here? Hopefully you're thinking log base 2 of 32 equals 5, because that's going to help you remember the exponential equation. Remember that base is 2, and logarithms are always looking for the exponent, so this is just saying 2 to the 5th equals 32. And this one, if you multiply it out, you know 2 times 2 times 2 times 2 times 2 is 32. The next one, they've taken some numbers out to see if you can do it without numbers, but it's really the same thing. You say log base a, so we know it's a, to the 8th power equals q. Remember, a logarithm is always looking for the exponent. So this is always the exponent, this is the base. In the exponential equation, we have the base and the exponent together, and the products on the other side. With a logarithm, we have the base and the product together, and we're looking for the exponent on the other side. And that leaves us with the last example of this type. Here, we've got x equals log base t of m. So t is my base. To the exponent is, hopefully you said x, and m is my product. There's converting those. What if we have an exponent and we want to go to a logarithmic equation? Well, this isn't any harder. You just write log base. What's my base? 10. 10 is my base. Remember, logarithms, I'm putting the product here, and the exponent is on the other side. Logs are always looking for what is the exponent. So when I take 10 to the negative third, I get 0.001. Couple more and you guys have this. Need to write a logarithmic equation, so it's going to have a log in it. Log base 2 of 16 equals x. And you could solve that. Here they're just asking you to convert. They're not asking you to solve, but you could. And the last one, e. Do you remember e? Hopefully you're thinking it's a number. It's a number. It's a number. What number is it? Hopefully you're remembering 2.71. So it's actually not going to come into play here, but I just want you to be thinking that way. We need to write in a logarithmic equation. So log base, what's my base? Log base e of my product is 70 equals my exponent, which is t. So once again, this is my base, this is my product, and this is my exponent. Now, some of you are thinking, I know there's a log button on my calculator. What does it do? Well, just use it. Type it. Log 10,000. If you have the TI, the log is next to the 7 button. If you type it in, you get 4 here. Log 100. Type it in, you should get 2. Log of 0.01, you should get -2. What base is the log? Notice there's no base here. Well, that's because this is called the common log. When I have a common log, it automatically tells me the base is 10. Notice 10 to the 4th power gives me 10,000. 10 to the 2nd gives me 100. 10 to the negative 2nd gives me the 0.01. All right. Now, this last one I've left off, let's take a look at that. Log of -3. Maybe you typed it in already. My calculator says error, non-real answer. Why? What's going on here? Well, let's think of this from a graphical standpoint. If I graphed y equals 10 to the x, it would look something like this with a y-intercept of 1. If I then graphed the logarithmic function, that would be y equals log base 10 of x. Don't get too hung up. This x and y is different than this x. Sorry. This x and y here is different than this x and y here. But the reciprocal function is going to have an x-intercept of 1, and it's going to be reflected across this graph. All right. Notice two things. One, this is saying, what's the exponent? Log base 10 of -3. It wants to know what's the exponent so that I can get -3. Well, if you look here, there are no y values of -3. That's down here. No matter what I put in to this equation, I will never get a y value of -3. Also, if you look here as an x value of -3, you'll notice we do have -3 on this graph, but my logarithm function doesn't have a value there. And that's why there's an error. So, don't stress too much about this, but that's what's going on there. The main idea is just understanding the relationship between logarithms and bases and being able to convert between them. Key point, the base here is the same as the base here. Logarithms are always looking for an exponent, which is the exponent here, and you always put a product into a log, which is the answer in an exponential equation.